force experienced by a charge in a magnetic field. Now I will consider a charge. There is a charge plus Q charge, which is just moving here in a free space. It continued to move in a free space. Suppose I will immediately apply a magnetic field in the path of this, in the path of charge moving. Then what happens? It cannot able to move straight. It cannot able to move straight. It just experiences some force. Why? Because when charge is stationary, it only produces electric field. But the charge is now not a stationary. When charge is moving, that constitutes current and the magnetic field around that. And that magnetic field as well as the magnetic field I applied externally, both will interact. When both of them interact, definitely it will experiences a force. Then there is no longer it moves in a straight path, it just bends. It experiences a force. And this force is called as magnetic force, or force experienced by a charge in a magnetic field, we will call. And how to apply the magnetic field? Do you know how to apply the magnetic field? Such a magnetic field, it is very simple. Just you have to keep north pole of the magnetic field over here. That's it. Or if you want one more, you can keep south pole of the magnetic field here. South pole of the magnet here and north pole of the magnet here. Then the field lines, these are the field lines. Magnetic field always start from north and terminate at south. So the magnetic field lines always start from north and terminate at south. So these are the magnetic field lines. In that field lines, if the charge goes, it experiences a force, and that force is given by, just look at the equation over here, and the force experienced by a charge is given by F is equal to Q into V cross B. Here Q is the charge we considered and V is the velocity of this charged particle. So V is the velocity with which the charge is moving and B is the magnetic field applied. So both the velocity and magnetic field are the vector quantities. So V cross B, you need to apply the rule of cross product. You know A cross B is equal to, in the previous year you studied about this in the first year, A cross B. A cross B can be written as magnitude of A and magnitude of B sine theta, right, multiplied by unit vector. So we can directly use it here. So V cross B can be written as VB sine theta. Then what is theta here? Theta is here the angle between V and B. Here theta is the angle between A and B. So if you have two vectors, vector B and vector A here, the angle between two vectors is represented by theta. But here the angle between V and B, where is the V here in this particular diagram? The direction of V is here and the direction of magnetic field is here. The angle between them is theta. So this is the angle theta. So theta is the angle between magnetic field and the velocity of the particle, the charged particle. So remember this formula. This is 3-mark question they can ask. And these are the cases, 3 cases. So if the charge is stationary, somewhere the charge comes here and it should be stationary now. When the charge is stationary, what should be the velocity of that? The velocity of the charge is 0. So if the velocity of the charge is 0, so in the equation 1, the velocity becomes 0. So then force is also becomes 0. So that means stationary charge do not experience any force. And the case 2, if the charge, I have a charge here, if this charge is moving along the field, it is moving along the field or anti-parallel to the field, parallel to the field or anti-parallel to the field. In that case, theta is equal to 0 or 180 degree respectively, right? If the charge is moving along the magnetic field, theta becomes 0, and if the charged particle is moving anti-parallel to the magnetic field, then angle between them is 180 degree. In that case also, the charge will not experience any force. It just moves in a straight path. Along the magnetic field, it just moves. So these are the two cases in which the charged particle will not experience any force. In first case, if the charge is stationary, it doesn't experience any force. Or if the charge is moving but parallel or anti-parallel to the magnetic field, again it doesn't experience any force. Then it can experience a force, maximum force, when theta is equal to 90 degree. That means the charge is coming from here, plus q charge is going in this particular direction. So perpendicular to the magnetic field. Now you see what is the angle? The angle is 90 degree, right? So in that particular case, it experiences a maximum force and it starts circulating around the magnetic field itself. That means if the magnetic field is like this and the charged particle is moving perpendicular, if there is no magnetic field, it continues to move straight in a straight path. But if you apply a magnetic field B, definitely it will experience a force and it start circulating around the magnetic field because of magnetic force. So from equation 1, what we can write, if you substitute theta is equal to 90 degree, the maximum force experienced by a charge is QVB. So in this case, if the magnetic field is like this, if the charge is moving either parallel or anti-parallel, it doesn't experience any force. Or if the charge is just stationary, which is not moving, again it doesn't experience any force. But if the charge is moving perpendicular, it experiences a maximum force. Or if the charge is moving maybe in this particular direction, maybe making some other angle than 0 or 90 degree, it moves in the helical path. Helical path is like this. So this is a magnetic field. If the charge entered in this particular angle, here it is not 90 degree and 0 degree or 180 degree, it start moving in a path like this. This path is called as helical path or helix. Remember that. Therefore, we can note that if theta is equal to 0 or 180 degree, the nature of trajectory or nature of the path is a straight line. Or if the charge is moving with angle which is theta is equal to 90 degree or 270 degree, the nature of motion, nature of trajectory is a circular path or circular motion. If theta is other than these values given here, then the nature of trajectory is helical path. That's what you're observing it here.